Hello again, everybody. Suchi here. We are doing areas of circles. Oh, and my water has been delivered. Thank you, kind sir. What good service. All right, so area of circles. We want to be able to apply the formula for area of a circle, but first we have to find that formula. So what we're going to do is we're going to take the circle and we're going to chop it up into triangle pieces. Now, the smaller the triangle pieces that we can make, the more accurate this representation becomes, but we'll get the idea. So here we've got blue, pinkish, blue, pink. So I've arranged these alternating. Now notice in this last pink triangle up here, well now I made it blue, but that last triangle, it was cut in half, and that's to accommodate the half on each side here so that it is going vertically up on the edge and not at a slant, because we wanted to look at this as a rectangle. So by chopping them up into these triangular-like pieces, it does create, excuse me, a rectangle-like figure. Now it's not perfect because these are slightly rounded on the bottom, but again, if we were to chop these up into really tiny triangles, a lot of them, it would create a rectangle-like figure. Now if we're looking at a rectangle, the base here is pi times radius, and that's because of the distance around a circle being the circumference, but we're only going halfway around because we're only including those blue sections. So circumference is 2 times pi times radius. But since we're only going halfway around, it gets rid of that 2 for pi times radius. And then the height of this rectangle is the same as the height of the triangles, which are halfway across the circle. So that's where the radius comes in, and that would be our height. And in order to find the area of a rectangle, we just do base times height. Since all of our pieces happen to fit into this rectangle formula, we are going to do the same, base times height, except our base is pi times radius, and then our height is radius. And so when we have the same value multiplied twice, it makes it squared. So area formula is really pi times radius squared. Radius times radius is the same as radius squared. So this is how you're going to see it, not usually written out like that. So let's use that formula. All right, example 1. Let me zoom out so you can see the dartboard here, entire page. So here's our dartboard down below, and it says, what is the area of the entire dartboard if the diameter is 451 millimeters? What's up, honey? Okay, so I know that the diameter is 451. That's all the way across. So if I were to imagine this all the way across like that, I only need the radius when I'm finding the area of a circle. Pi times radius squared. So first we need to figure out the radius. So I need half of the diameter to get the radius. This is top secret information. Top secret information there. Okay, so all I did was take that 451 and I chopped it in half, and I got 225.5, and that would be millimeters for my radius. So now I'm going to take that and plug that in. But if you are not familiar with the number pi, you probably have no idea what to do here. So, FYI, pi is an everlasting number. It goes on forever and ever and ever. But we usually round it to the value 3.14. Now, if you use 3.14, or if you use the pi button on your calculator, you're going to get two totally different answers. They're going to be really close, but one's going to be a little bit longer looking than the other one. I personally do not care which one you use. Just make sure that you are showing your work so we can understand where you're getting the number from. So if I'm finding the area of my dartboard, I'm going to do pi times my radius, 225.2 squared. Hang on. Isn't radius squared the same thing as diameter? Why did I have to do all that work? Ah, it's not. So 2 radii make a diameter, but radius squared is multiplying the radius by itself. So it is completely different, so make sure that you do calculate it appropriately. Now I'm going to replace this pi with 3.14 so I can get a nice rounded off number. So 3.14 times 225. Oh, I wrote that wrong. Sorry guys, this should be a 5, not a 2. Back the train up. There we go. I don't know why it still shows me eraser. Okay, 225.5 squared. Holy bananas. Okay, so I get an area of approximately 159,669.785. Wow. Okay, but this is millimeters. So if I think about a millimeter, that's pretty small. So, okay, that makes sense. We got 159,669.785 millimeters squared for the area. Okay, what is the area of the inner circle? Inner circle. From the inner bowl to the triple ring. The inner bowl to the triple ring. I don't know what the triple ring is. Oh, it's this one here. Just read, Suchi. Okay, here's triple ring. So we're looking for the area inside here. Okay, so we just found the area of the whole thing. Now we're looking for that inside circle area. Okay, they tell us it has a radius of 115 millimeters. Well, that's good because all I need is the radius for the formula. So area equals pi times radius squared. And again, I'm going to replace that pi with 3.14. 3.14 times 115 squared. Now remember, 115 squared just means 115 times 115. So if you're just using a basic calculator like mine, you just type it in times twice. Not times 2, but times itself. So this comes out to be approximately 41,526.5. And that would be millimeters squared, because again, this is looking for area. Okay, what is the area from the triple ring to the edge of the board? Well, they didn't give me any numbers here, so let me process this. Triple ring to the edge of the board. Okay, triple ring is right here, and then to the edge of the board, so that's like all of this stuff out here. All that in pink. So if I take the whole dartboard and remove that center piece, that would give me that pink area. And we've already found both of those numbers. So I'm going to take the whole area, 159,669.785, and I'm going to take out that inner circle, 41,526.5, and that's going to get me that outer ring from the triple ring to the edge. Okay, 159,669.785 minus 41,526.5. And I get an area of 118,143.285 millimeters squared. All right. Which space is more likely to get hit based on its size? Well, I suppose if you're throwing darts and you're using probability, knowing that maybe you're not a dart like savant or something of darts, just an amateur, just throwing them, this inner circle is clearly smaller than the space out here in the pink area, which is also shown by the number. 41,000 and some is much smaller than the 118,000. So I would say that outer ring is a better chance of getting hit than the inner ring. And I know nothing about darts, so I don't know. I know the bullseye's good, but I'm sure there's other strategy that I have no idea. Like this area says out of play. I thought that would be counted, but all right. Oh, maybe they were only talking about to the ring then. If that's out of play, because that wouldn't be any good. But we'll just say that that outer space, so the area from triple ring to the edge is clearly bigger. Yay! Good work. Ugh, another two. Okay. Basketball hoops allow for a variety of sizes of basketballs to fit through, which I didn't know that there were different size basketballs until my children actually played basketball, because I never played basketball. The area inside the hoop at the school is 255 square inches. Well, that seems ridiculous that you would do a square inch for an area, because it's square and it's a circle hoop. No, remember, square inches just means like space. All right, what is the maximum circumference of a ball that can fit in the hoop? Well, it might be a pretty big ball, I would say. All right, so step one says, using a T-chart and the area of the circle formula, solve for the radius. Okay, well, we have the area, that's right here. So area of the circle formula, area equals pi times radius squared. We just need to do a T-chart. So I'm going to plug this 255 in for my A. 255 equals pi times radius squared. I'm on T-chart. Okay, now remember pi is just the number 3.14. So really I'm multiplying both sides by multiplying this right side by 3.14. The opposite would be to divide by 3.14. Calculator, 255 divided by 3.14. Okay, I'm going to have to do some rounding. It's not going to be a perfect number, but we get the close enough gist. So we'll say 81.2, and this is radius squared. Okay, now think, how do you undo a squared? A squared is something multiplied by itself. But we want the opposite of that. How do you divide by itself if you don't know what itself is? So really, the opposite of a squared is a square root. And if you remember from your algebra days, technically, there's two correct answers. One's going to be a positive number, one's going to be a negative number. But you can't really have a negative length on a basketball. So we're just going to go with the positive answer. I got to take my calculator and turn it to the side, find my square root button, and my radius comes out to be approximately, now I'm rounding this, 9.011. I'll just say 9. That's close enough. All right, now let me look back at the label here. This was in square inches, so that means the radius here would be inches. 9 inch. I have no idea what the diameter of an actual basketball is, but this is the radius. So imagine your basketball from the center straight out. That's a 9-inch radius. That seems pretty big to me. I think about my hand size. I don't know. Okay, step 2. Using the radius, calculate the circumference, because they wanted to know what was the max circumference that could fit. Now, we didn't actually talk about circumference, so let's write down that formula. Circumference is 2 times pi times radius, or you can write it as diameter times pi, because 2 radii make a diameter. So we have the radius. I'm going to plug in our radius, which was the length of 9. And so this would be 2 times 3.14 times 9. 2 times 3.14 times 9. All right, we get a circumference of approximately 56.52. Now, some of you might be saying, why are you saying approximately when that came out to exactly 56.52? And the approximate is because we didn't use the pi button, we used the approximate for pi. So we technically rounded within the problem itself, which is not a great idea. You should wait to the end to round, but we're getting an approximate number, we're close enough. So our circumference is going to be 56.52 inches. That seems like a really big ball, but I have no idea. So maybe you guys could educate me on that. Okay, yay! More practice. Okay, these ones are just like your test. So you're going to get a circle and you're going to have to figure out, okay, what is the area? I got to work backwards, so I just plug it in. So in this one, it says find A for area. So that's nice because you just plug it in. Pi times radius squared. So I'm just going to plug the number 4 in for R, and bam, I'm done. So pi is 3.14. Radius was 4 squared, and 3.14 times 4 times 4. Because 4 squared is 4 times 4. And so this comes out to be approximately 50.24. What was the label? This was inches. So this is inches squared for our area. Nice, easy. All right, now I'm going to go down to this one. And I want you to do the same thing, except we're finding the area given the diameter this time. So remember, diameter is all the way across. First, you got to figure out what is your radius, and then plug it in. So go ahead, find the radius, plug it in, find the area. All right, you should have got a radius of 7 centimeters. So we'll replace that with 7, 3.14 for pi. Hiccups. So area is approximately 153.86 centimeters squared. Voila. Okay, now we're going to go back up because the ones that are left over here are using T-charts to solve. So going back up over to this one, this time they give us the area and we're trying to find the radius. So I'm still going to use that same formula. But instead of plugging in R, we're going to plug in the number for A. And this number looks weird because it's got a pi next to it. So that actually means we need to multiply these together first to get our area. It's called a perfect answer or an exact answer. If you multiply the pi in, it creates a decimal, and the pi number goes on forever, so our answer would go on forever. But you don't actually have to do the math. I can just take this and plug it in over here. Voila. Okay, now because R is missing, we have to do a T-chart. But what's nice about having that pi there is I have pi's on both sides. Those will cancel out because technically I would divide both sides by pi and bam, they're gone. So now we're left with 49 equals R squared. You might think, I know what number that is because 7 times 7 is 49. To get that on the calculator, you would do the square root. And technically, yes, -7 is also an answer, but you can't have a negative length for a radius. That doesn't make any sense. So this would be 7 centimeters. All right, same situation, except once you find the radius, then double it to find the diameter. So go ahead and try doing a T-chart on your own for this one. Okay, take that 144 pi, plug it in for capital A, and then do a T-chart. We're going to divide by pi on both sides, which makes it really nice. They just cancel out. You could change it to 3.14 if you wanted to, but they're gone anyway, so it doesn't even matter. And then I've got 144 equals radius squared. To undo the squared, take the square root of 144, and that comes out to be 12, or -12, but again, doesn't really matter. So my radius here is 12, but the question said, what is the diameter? So I actually need to add on another 12. Diameter in this case would be 24, and that looks like a meters. There we go. Okay, last two examples. These ones are giving us the area without the pi symbol in it. So we're still going to do a t-chart. But we won't be able to just cancel out the pi's. So what I'm going to do is I'm going to take that 50.27 and I'm going to replace a with that number. And I'll do my t-chart. Now, because I can't just cancel out the pi's, I remember that pi is really 3.14. So I'm going to divide both sides by 3.14. And when I do that, the pi does get canceled, and I have r squared left. And then 50.27 divided by 3.14 comes out to, oh, really close to 16. That's nice. That's approximate because I rounded, but 16 is a perfect square. So when we take the square root, we get a really nice answer of 4, and that is the abbreviation for miles. Oh, that's not even what they asked us, though. They asked us to find the diameter. So I got to double that. Diameter equals 8 miles. Because 2 radius makes a diameter. All right, your turn. Try to solve for r. Plugging in our area for capital A. 175.9 equals pi times radius squared. Now remember, we don't have the pi to cancel, so I gotta think about this as 3.14 being multiplied. Opposite of multiply is to divide. This little eraser symbol's throwing me off. R is approximately, I guess, 175.9 divided by 3.14. That comes out to be 56-ish. And then, oops, that's not r, that's r squared, because I still got that 2 there. So then I got to take the square root. And I'm pretty sure 56 is not a perfect square. Yeah, so it's just going to come out to a decimal answer. So you should have gotten about 3.8-ish. But if you routed differently, no big deal, as long as you're close. And then this is a length, so that would be feet. Fantastic. All right, way to go, everybody. I think our summary is next. Let's just double check. Or maybe there's no summary. Cool. All right. Thanks, everybody.